Okay, welcome to lesson 1.5. We're going to be estimating whole numbers, which means we're going to be rounding whole numbers. So it says sometimes we need to organize or recognize the value of large numbers to understand the world around us. When numbers are very large, it is easier to talk about numbers as rounded values. Also, when all numbers are not needed, numbers are often rounded to give approximate values and quantities. That just means amounts. So when we don't need an accurate answer, we can round it. So it says this is where we need to remember our place values. So if we got a highlighter, we're going to highlight place values there. Place value of the number, that is the value of the number based on the position in that order. So we're talking about the order of our place values, starting at the ones and moving to the left. Okay, so here we are with our first number. It's the numbers 1 through 7. So 1, 2, 3, 4, 5, 6, 7. We're noticing that if we draw this number in digits, the number itself has spaces. So I've got a space here and a space here. All that's doing, sometimes we would put commas, all that's doing is showing the differentiation of the numbers. So that means the first one is talking about the hundreds. The next one would be talking about the thousands. Then we would be talking about the millions. What comes after millions? Billions. And what comes after billions? Trillions. Okay. Now it wants the underlined digit. So if we have an underlined digit, how do we actually round numbers? Well, there is a rule. So if I have my underlined digit is a 5 at the moment, it's in the tens position. So that means my number on the end is going to turn to a 0 because it's in the tens position. It also tells me that if I'm rounding that 5, how do I round that 5? Well, you always look at the next number after it. So I'm going to look at the number after the 5. And the number after the 5 in this case is a 6. So what does that 6 tell me? Well, the golden rule is 0 to 4, round down. 5 and bigger, 5 to 9, you're going to add 1. So this number is a 6. I'm going to add 1 to the 5, and the 6 disappears and becomes a 0 because it's in the tens position. So I need to have a 0 at the end. So rounded is going to become 3, 4, 6, 0. The tens position, we see a 0 at the end. What if it was in like the thousands position, like it's showing in the next question here? We've got the number 775 and then 525. The 7, second 7 is the number they want to talk about. So if that's the number I'm talking about, I need to look at the number right after it on the right. And that number is a 5. And what do we know about 5 to 9? It's going to make our numbers do what? They're going to go up. We're going to add 1. So, and all of those numbers at the end, because it's in the thousands position, we're going to end with 3 zeros because 3 zeros means 1,000. So that 5 here is going to make that 7 become what? What would the 7 become? An 8. Good. So we're going to add 1 to the 7 and we end up with 7, 8, 0. And then I put the other zeros at the end. So I'm in the 10,000s place. So if it's the 10,000s place, that means it's got to have 4 zeros. So we're having 3 zeros for the 525 at the end here. We're having 3 zeros, and then that 75 turns to an 80. So that's what's actually going on. We're rounding the digit 75. So 75 will round to an 80. Well, what if it was 74? What would it round to? Would it round up to 80 if it was 74? No, it would round down to 70. Okay? All right, let's look at the last example here. It says, I'm looking at the 4. Okay, well, if I'm looking at this 4, I need to know what the number is after it. Well, there is no number after it. Okay, because that would be decimal 0. I would have to put a decimal there. So if I were to round that number, is a 4 going to round? We don't know. If it's in the ones position, this is where we have to look at the first decimal number. The first decimal number. So let's pretend that decimal number was 0.3. What would a 3 make us do? Is a 3 going to make us make it bigger or stay the same? So for example, let's say I had the number 4.3. I'm saying that the end would look like this. So I've got those other numbers in front, 3, 2, 1, 9. I've got a 4.3 on the end. What do you think that 3 is going to make the 4 do? Does it make it do anything? No, it makes it stay the same. So this guy would disappear and it would stay the same. Okay, well, let's do another example. What if I had a 4.7 at the end? What if that number after the decimal now, the very next number, it's between 5 and 9? What do I know about the numbers between 5 and 9? What will they make the number do? They're going to add 1. Good. So that means I'm going to add 1 to my 4 and cut this guy off the end. So then the end number, whoopsie, I'm going to add 1, not 4. I'm going to add 1 to the number 4. So the end number would become a 5. So this number, I'm still dealing with this number down here. It would become 32195 if there was a 0.7 at the end. It would stay 0.4 if there was a 3 at the end. Okay. Now we're going to talk about the actual rounding rules that we've been discussing. So this is showing us our place values just in case we forget. So we call the first three are in the hundreds. That's our hundreds, ones, tens, hundreds. That's our maximum amount. The next 3 numbers are in which place values? Well, they would have 3 zeros at the end minimum. So they're in the thousands. Good. So these are the thousands. And then after thousands, we have millions. After millions, we would have billions. Okay. So we want the definition. What does it tell us? Well, it says rounding is the act of making a number simpler, but keeping its value close to what the original is. So it's keeping the value close. So let's say I've got the number 1,030,000 people that voted in a city election. You could say that there was about 1 million people, okay, that voted. This is known as, what would we say? Rounding. Okay, this is known as rounding or doing what to the number? What would we call it? Rounding or estimating. So rounding and estimating are pretty much the same thing. Okay, so we have an example. It says we talk about populations of places. Most of those numbers are very large. So we tend to approximate the values. In these cases, blank are used as placeholders, zeros. So just as I showed you above, they use zeros. I'm going to highlight it in pink here. They use zeros at the end when you are actually rounding. So whatever place value you're rounding to, the numbers at the end will all change to zeros. All right, turn your page. We have a few examples on the next page. Okay, so take a look at what it's talking about here. It says the distance, here's some large examples that we need to round. So the distance between the Earth and the moon. Well, do we know exactly how far it is? Well, do we have somebody standing on the moon with a measuring tape and somebody on the Earth with a measuring tape? No. Okay, they are approximating, and approximating means rounding or estimating. So they are estimating how far it is. So they're saying it is 385 million. These are in the millions. Million meters. That's how many million meters it is. And then it says, yeah, they would convert that in science then. Yes, they would. They would convert it actually to kilometers, and then they would convert it to light years after the kilometers. Now, if you remember what the word circumference means all the way around something, okay? So it's basically perimeter of a circle. So circumference, we're going to write that down. That's perimeter, which means distance around. Okay, so perimeter or distance around a circle. That's what it is. So if we were to cut the Earth in half and just to see a diagram of a 2D object of the Earth, it's a circle, okay? So it says the circumference all the way around it. If we were to walk along the equator and walk and start in one spot and walk all the way around and get to back where we started, they say that it is this far, 39,930 kilometers or meters. That's a long ways. Could you imagine having to walk that? My goodness, I think we'd be sore. I think we'd be a little tired. Then it's saying the circumference of the moon is about 6 million meters. So, large numbers. This is where we need to round them. Because what if there was lots of numbers at the end of that? What if it was like 176.234? Well, we don't need to know exact numbers for this. We are just giving approximate values. Okay? So, when do we do it? Large numbers. And where do we see large numbers? Well, newspapers, they're going to round up numbers. How come? To save space for printing. So if they were to say we've got this many million, 10,490,721. Well, that would round. The 4 would not round the 10 to an 11. So that means it's going to round down to just 10 million. So you're going to notice newspapers will round numbers very much to save space. You'll probably notice if you're texting with your friends or playing games, you're also rounding numbers without even thinking about it because you're trying to save space. Okay? That might be true too. Now, adding and subtracting large numbers mentally, it's way easier if we round them first. So if I said I have 50,720 minus 20,830, wow, that's a big number. I'd have to write it all down and subtract. Versus if I said 50 million minus 30 million, 50 minus 30 is a 20, I'd say I have 20 million. So when we break it down into smaller, easier numbers, then it makes it easier for our mental math as well. So what are some other situations we round? Well, temperature. When we look at our, our weather network, and we're looking at the weather in the morning to see what we should wear to school. Is it going to be boots weather or can I wear my shoes? Do I need my heavy parka or can I wear my spring coat? Those kinds of things. Yes. Well, this guy's saying I have 0.7 degrees Celsius. Well, yeah, that's very accurate. But you know what? For example, I live in Red Deer. Sylvan Lake is on a higher. So Red Deer's, we go down. So for example, here's Sylvan. Red Deer goes down a hill and we're in a valley. So down here in Red Deer, I'm usually a little bit cooler. You'd think it would be warmer, but it's not. So in Sylvan, sometimes when it snows, sometimes where I live in Red Deer, it doesn't. Sometimes here when it's colder, sometimes in Red Deer, it's a little warmer, or vice versa. So it depends on where you're living and the altitude you're at. Now, if you were going to go to Rocky Mountain House from Sylvan, you're going to go up even higher. Why? Because we're getting close to the foothills of the mountains. So as we go higher too, we're going to be rounding distances. Okay. So am I going to say the distance from Red Deer to Sylvan is 17.24 kilometers? I'd probably round it to 18. Okay, same thing. If I'm going to round from Sylvan to Rocky, if it's 45 kilometers, I might say, or 46.2, I might say it's 45 kilometers or 50 kilometers. Okay, so rounding distances, also money. When you're going shopping and you've only got a $20 bill for lunch and you're like, okay, well, I really want a slush and I owe my friend $10. So I really can only spend $10. So I need to budget what I can spend my money on. So then you're like, okay, well, maybe a slushie costs $2. Maybe I want to have taco in a bag at school. I don't know what I need the money for, but you're going to round it. Okay. Yeah. Or don't pay your friend back. Yeah. Right away. Wait another day.
Wait for like a year.
A year? Oh, goodness. That friend won't lend you any money anymore, hey? So money is a big one because when you go shopping, you never want to take more to the till and then be embarrassed and say, oh, I don't have enough money. Now I got to put some things back. That's no fun. So instead of putting things back, we try to round things up in our brains, or we have our phone calculators out so that we know that we don't go over the money we have. Okay, so money's a big one. So here are our general steps for rounding any number. So step 1 says, and we are going to put a number down. So I'm going to put the number 6, 7, 1, 2, 3, 5. And it says, I want to round, I'd say I'm going to round the 2. All right. What place value is that 2 in? Well, let's start at the right. The 5 would be in the ones, then the tens. What's after 10? Hundreds. So this guy is in the hundreds place value I'm looking at. So whenever we look at a number, we look at the number right after it. What does that 3 tell me? Well, let's take a look at what the steps say. So it says, look at the number to the right of the place I want to work with. Well, I want to work with the 2, so I'm looking at the 3. It says if that number is 4 or smaller, you round it down. Round it down means they change to zeros. So that means this number here would be 200. That's how I would round that down. That's what rounding down means. Now, let's say I've got that same number, 6, 7, 1, 2, 3, 5, and I want to round the 6. Let's say I want to round that 6. Well, I'm going to now look at the 7. You look at the number directly right after it. So what does that 7 tell us? Well, it's 5 or bigger. So that means I round up. By rounding up, we add, we add 1. So we go plus 1 to the number that we are rounding. I wouldn't say plus 1 to the 7. It's plus 1 to the number you're rounding. And then all of the other numbers change to zeros. So just like in the other question, they all changed to zeros, but the 2 didn't change. He didn't add 1. Here, the 6 is going to change to a 7, and then all the other numbers change to zeros. The 5 goes to a 0, the 1, 2, 3 goes to a 0, and that 7 would go to a 0. Okay, and we're left with 700,000. Let me just write my 1 and my 0 over a little bit further so you can see the separation. So it'd be 700,000 is what it would be. Okay, so that's our basics in our rounding. We look at the value where it wants to go. We find out what number it is. Okay, and a good way to remember is this. When we're looking at our place values, I'm just going to go up to this to show you. If I'm looking at this place values, over 1 literally means 1 and no 0. Okay, here, how many numbers are after the 6? 1 number's after the 6, so there's going to be 1 0 on the bottom. How many numbers are after the 5? 2 numbers, so there would be 2 numbers on the bottom. That's how you work with those numbers. Okay, that's how you know how many zeros are on the bottom. The first number in the ones, there's no 0. It's only a 1. As you move to the left, you're going to add a 0 for every place. Okay, and that's how we round. So let's look at those examples on the next page here. So we have a little chart, and it wants us to round to different places. And then we're going to round using number lines. So there's a couple different ways we can round. All right, so this one wants 100,000s. Well, first of all, I have to look at the 100,000s. So here's my hundreds, there's my thousands. That means 100,000 would be the 8. Okay, so I've got 6, 8, 3, 1, 279. I'm just writing it out. Don't write the numbers, please. I'm just writing out what numbers I am. So now I've got the 8. I'm looking now at the 3, the number behind the 8. What does that 3 do? Does it make the 8 change, or does it make the 8 stay the same?
It makes the 8 stay the same.
8 stays the same. Good. And the rest of the numbers change to zeros. So now the 3-1 and the 279 change to zeros. Okay. Now I'm going to round to the 1000s. I'm going to put the number above it. 6, 8, 3, 1, 279. I'm just going to put the number above. 6, 8, 3, 1, 279. Just so we can see it. Whoops. It'll be easier that way. 6, 8, 3, 1, 279. I'm going to put the other number below it. 1, 2, 4, 2, 8, 6, 5, 3. 1, 2, 4, 2, 8, 6, 5, 3. 1, 2, 4, 2, 8, 6, 5, 3. This is going to help us round when we need the numbers. 4, 2, 8, 6, 5, 3. Okay. Now I'm going to look at the original number. So right above where it says 1000. So if I'm looking at the 1000 spot, the 1000 spot is my number 1. You need to look at the number after it. What does the 2 tell the 1 to do? Stay the same or add 1? What do you think? Is it going to stay the same or is it going to add 1? Remember, if the number is from 0 to 4, it's going to stay the same. It's not going to add 1. So that means my 6, my 8, my 3, and my 1's going to stay the same. That means my 279 changed to zeros. Okay, that 1 did not change. The 1 did not move to grow bigger. All right, now we're going to look at the millions. So if I look at the millions, okay, here's my millions place value. That's our 6. So I have to look at the number right after it. What does the 8 tell the 6 to do, Riley? You got to go put your name up on the list. Right now, Caleb's gone, and then Noah and Lennon. Okay, what does the 8 make the 6 do? It is from 5 to 9, so we're going to add 1. We're bumping it up. So I'm going to put plus 1 on my 6. I'm going plus 1. And now all the 8s, you cross them off. All the numbers after now change to zeros. So now it's going to be 7 million. Those other numbers change to zeros. Gage, you need to stop doing that. Put it in the recycle bin. Okay. Seriously, now, put it in the recycle bin.
Are you serious right now?
Didn't even finish it.
Did I stutter?
Can I finish it?
Yep.
Okay.
And then stop horsing around. That's not okay. I didn't even pause. Okay, here we go. The next one, it wants 10,000s. So I need to find where the 10,000s are. So my first 3 numbers, I deal with hundreds. The next 3 numbers are the thousands part. So that means I'm dealing with these 3 numbers right here. So the 10,000 spot is the 3. So now I'm going to look at the number right after the 3. The number right after a 3 is a 1. Does my 1 make the 3 add 1 or stay the same? Stays the same. Good job. So I'm going to end up with a 6, an 8, a 3. The 3 stayed the same. Now all the other numbers changed to zeros. So cross them off on top because they all changed to zeros. So you should have 4 zeros at the end. Okay? So get in the habit of crossing the numbers off that become zeros. That'll help you remember what your number becomes. All right, we're going to do the same thing for the numbers below. So I wrote them right below each one of them so that we can see what to do to the digits. So I want 100,000s. Well, 100,000s, that's going to be this one right there. So I'm going to look at the 2. What does the 2 make the 4 do? Anything? No, he says stay 4. Number 4, you got to stay a 4. So he's going to be 12 million. The 4 stays, all the other numbers change to zeros. Okay, so the 4 stayed the same and every other number changed to a 0. Okay, make sure you've got this written down because you don't want to end up in Zap class to have to redo it all. Zap means if you're not going to work in my classroom here, you're going to be after school working with the vice principal, Tuesdays and Thursdays. Then that's called defiance and you'll be suspended. Miss Lambert will deal with you and you may not end up back in my class ever again.
Are we suspended?
It's high school. Get over yourselves. It's time to grow up. You get suspended for defiance, absolutely. Okay. Taking a look at the next one, 1,000s place. The 1,000s place is right here. Oh, wrong color. The 1,000 place, we got to put him in yellow. So yellow guy is the 1,000s. So we look at the number right after him. It's a 6. So what does the 6 do? Makes an add 1. Good. He's going to go up. So we're going to add 1 to the 8 and all the other numbers change to 0. So cross them off. So now we're going to have 12,429 and then 3 zeros. Okay, so the 8 becomes a 9. We add 1 to that 8. I'll just make that a little clearer. So the 8 becomes a 9. All right, let's take a look at the next one. We want to round to the millions. So millions is in the 2 spot there, that 12, that 2. Now I'm going to look at the number after the 2. It's a 4. Does the 4 make my 2 stay the same or add 1? Stays the same. Good job. So stays the same. Everybody else crosses off and becomes zeros. So the 12 stays, and now I've got zeros. 12 million. Okay, so that would round to 12 million, even though it's close to 12.5, because 428 is close to 500, but it didn't make 500. So, all right, the next one, 10,000s place. So if we're looking at the 10,000s, that's the number 2. So now we're going to look at the number after it on the right. Always the number on the right, not the left. So the 8 is 5 or bigger. 5 or bigger makes us add 1. Good job. So we're going to add 1 to the 2, and then the 8 and all the other numbers become zeros. I'm just going to put the +1 down there because it's going to get in my way. Okay, so now I'm going to get 12,430,000. And all the other numbers turn to 0. So you should have 4 zeros at the end there. Okay, now we're going to do part B. Part B is using number lines. And you're going to have to know how to use number lines as well, because they could have a picture of a number line and ask you what they did to the number line. So if we take a look here, it says a number blank has numbers placed in order. Well, this is a number line. A number line has numbers placed in order on a straight line. The number values increase. Yeah, it's a line graph basically. So they increase, meaning they get bigger from left to right. Okay, so if we have 0 on the left, they get all the way bigger. Okay, and that's what we can see. So if I want to round to the nearest 10, and I've got these numbers right here. So 11, where would 11 be found? Well, it's saying 11 is right here. Well, if you want to look at the number line, if I'm rounding to a 10, that means I'm counting by 10s. So it would be 10, 20, 30, 40. So is the 11 closer to the 10 or the 20? Visually, we can see he's closer to the 10. So the 11 would round to 10. Okay, so this guy becomes a 10. Okay, the 7, we can see over here, 7, is he closer to 0 or closer to 10? He's closer to 10. So we would say he rounds to 10. So 7 would round to 10. What about the number 19? Look how close he is. Is he going to round to 20 or to 10? 20. He's right beside it. Okay? He's got to be halfway or more. So the 19's going to round to 20. Well, look at that number 15. Number 15 is right in the middle between 10 and 20. What happens if it's right in the middle? They're showing us with an arrow.
It's his own number.
It's his own number, but if I want to round him to a 10, that means he has to become a 10 or a 20. So which one would he go to? The bigger one, because he ends in a 5. So remember, if the numbers end in a 5, a 6, a 7, an 8, or a 9, they're going to go to the bigger number. So for example, if you've got a highlighter, if not, circle them. All of these numbers right here on the number line, because that would be the number 5, the number 5, 6, 7, 8, 9, all of those are going to round to 10 because they are 5 or bigger. Same as these ones. 15, they have a 5 in the number. 16 has a 6 in the number. If the numbers have any of these as their last numbers, if they've got any of those, like these ones will, they're going to round to the bigger number. That's what's happening. Okay? So the 15 will round to a 20. Now look at the number 24. The number 25 would be right there, and that would be halfway to the number 30. Now, if I said, who is he closer to in ones, you would say he's closer to the 25. But if I said tens, that means it has to have 0 on the end. So is he closer to a 20 or a 30? They're showing us 20 because the number at the end is 4 or smaller. So if it's 4 or smaller, it rounds down. So that's why this guy's going to round to a 20. Pardon me? Yeah, exactly, estimating. All right, we talked about all of those. Another way to think about rounding is to think about the hill. Okay? So these guys, the numbers are going to roll down the hill. Here, these guys on this side of the hill, you're going to add 1 every time. These guys are going to stay the same. Okay, so if you're on the up, going up, 1, 2, 3, 4, so 0 to 4, the number stays the same. 5 to 10, the number's going to get bigger. Okay, and you're going to see that as a mountain as it goes. And all they've done is they've taken the number line and just made it into a mountain. All right, let's try to the nearest 100 now. So now I want 2 zeros at the end. So what we're doing again is we're looking at, if I want the nearest 100, I'm looking at the number next to it. So I'm looking at the middle number of a 3-digit number. So what I'm looking at is the middle number here, the 1, the 8, the 2, the 5, and the 2. All those middle numbers, because that's in the 10 spot. If I want to round to 100, I have to see if those numbers are 4 and lower, or are they 5 and bigger. The 5 and bigger will round up. The 4 and lower will round down. So 110 is going to round to 100 right here. He's going to round down to 100. And the reason he does is because the number is a 1. So anything between a 1 and a 4, that's rounding down. So all of these from right here over would round down. All of these up would round up. Okay, because again, use your halfway point. That would be 150. The numbers with a 5 are going to round up. So now I look at the number 180. 8 is bigger than a 5. And if on the number line, if you look, he's bigger than halfway. So halfway, this didn't get written very well. Halfway here would be 150. So again, look at halfway, 250. Halfway, 350 would be over here. All right, look at that second number. The 180 is going to round to 200. 320, if I look at 320 over here, that's this number here. 320, the number 2 will round down. So 2 is going to get round down and become 300. Now 250 is right in the middle. So what did we say about the guys right in the middle? Are they going to round down or are they going to go up?
No, they're going to go up.
They're going to go up. Exactly. So this guy's going up and he's going to be said 300. $224. If you've got $224, is that going to round down to 200 or up to 300?
200.
200, because you don't have over half. You got to have over half, so half or more to round it up. And 2 isn't half. So this guy's going to round down to 200. Okay, and they've got all of these with their explanations. Now we're going to do these ones, and we're going to see if we can get them right. All right, I'm going to give you guys about 3 or 4 minutes. I want you to try it on your own, and then I'm going to write the answers right beside to see how you did. So I want you to try that on your own. Numbers 1 to 5. I'll give you about 5 minutes, and then we're going to go through them together. Okay, so give that a try on your own. Okay, we had a couple minutes to look at our examples. This guy is between 10 and 20. Who is he closer to? We say 20. This one is between 70 and 80. He is closer to 70. In the hundreds, I look at the 5. That's where I would start. So this guy is between 500 and 600. Who is he closer to? 500. And where am I getting these answers? Well, remember, I'm looking at the number after it. So if I look at this number, the 8 is going to make it round up. This number here, the 3, the 7 stays the same. 3 doesn't make a 7 round up. If I look at a 1, 1 does not make a 5 round up. So 5 will stay 500. The next one is 1,000. So I'm going to look at the number 4. Does the 4 make the 8 round up? It doesn't make it round up. So I'm looking at the numbers between 8,000 and 9,000. And he's almost halfway, but not quite. So that means he'll round back down to the 8,000. Now this one wants 10,000. So 10,000 is the 4. So I'm going to look at the number after it, the 1. The 1 will not make the 4 do anything. So I have 40,000 to 50,000 is where my number should be. And it's going to round down to the 40,000. Okay? All right, turn your page, please. Now we're going to be talking about rounding really large numbers. And what are we noticing when we round? The numbers that we take off on the end, if we round up or down, they all become zeros. So that's something we have to remember. Come on. Come on. Should have seen me first block. Okay.
What was it like first block?
I'm brutal. They finally got the technology working. Okay, we're going to round to 1,000 now. So that's one of a couple of examples we saw. So if we look at this number, 1,200, 1,200 is in between 1,000 and 2,000. And who is he closer to? 1,000. Yeah, he's closer to 1,000. So we can look at each of those numbers and see where they locate on a number line. When we see it visually, we can see if it's halfway or more. If it's halfway or more, it's going to round up to that larger number. If it's less than halfway, it's going to round back down to that lower number. So in this case, let's take a look down at Glenn. Glenn spent $1,238 or $37 on a new computer. We're going to round that to the hundreds. So how much did he spend? Well, if I want to round to the 100, I will highlight the hundreds place, and then I got to look at the number after it. So the number right after it's a 3. What do we know about 3s? Are 3s going to make a number go up or stay the same? It's going to stay the same. So my 1, 2, 3, 7, the 3 and the 7 are going to disappear, and it's going to become 1,200. It's going to round down because the number is between 1,200 and 1,300. And we have to see which number on the number line would it be closer to. It's closer to 1,200. Okay? What about really large numbers? Well, we talked about populations already in a couple different lessons. These numbers are huge. And like we talked about in newspapers, and even if you're online in your social media, a lot of them, especially because of Facebook and a lot of your social media accounts, they only allow you a certain number of words in your posts. So that means you're trying to simplify and reduce the number of letters and words you're using. That's where we round large numbers. So for example, Ontario, if I wanted to round it to the millions, The 6 would round the 3 to a 14 million. Now, if that was in the paper, what would they write beside it? They would probably write 14M for million. Okay, this is probably what they would write, just to reduce the amount of space. Same with the next one. We have the number 8214700. If they're rounding to the nearest million, again, nearest million, you're looking at the next number, the 2. The 2 doesn't make it do anything. So it's going to round down. All these numbers after, like we know, we cross them out, they all turn to zeros. So all those numbers we would cross out. Same as this one. The 6 is going to make the 4 add 1, but then they all change to zeros. The 4 does not make it do anything. The 1, pardon me, does not make the 4 do anything for Alberta, so it's going to round down to 4 million. Same thing with this one. The 1 for Saskatchewan does not make the other one do anything. We just cross them off. They all become zeros. Okay? So that's how you round very large numbers. We've got 3 true-false questions to finish our lesson. So these ones are rounding. This one is rounding to the millions. We need to see if this guy rounded correctly. So if I'm rounding to the millions, that means I want the 6, and I need to see if the 6 is going to change. Now, the number after the 6 is a 4. Does the 4 make the 6 add 1?
No.
No, it doesn't. So this guy is going to cross off. They all become zeros. These all become zeros, which they did. So this guy is true. Okay, the 6 did not round up to a 7. It stayed a 6. Let's look at the next one. I have 1,499,402. Again, I'm wanting to round to the millions. If I'm rounding to the millions, I'm looking at the 1, but what does that 4 make the 1 do? Does the 4 make the 1 add 1?
No.
No, they just cross off. They don't add 1. So this guy is false. What should it round to? It should round to 1 million. So a 1 and 6 zeros. It should not be 2 million. It should be 1 million. Now, people might think, oh, well, that 499,000 is pretty close. Well, it's not halfway, though. It has to be halfway or bigger. All right, the next one. Did they round properly to the nearest 10 million? So this one is 10 millions. So if I'm rounding to the 10 million, I'm looking at the digit 1, and then I look at the 9 right after it. Is the 9 going to make the 1 add 1 or stay the same?
Add 1.
It is going to add 1. So this guy's going to add 1. And then the 9 and everything else changed to zeros. So did he add 1 and they changed to zeros? Yes, it's true. Okay, everything else changed to zeros. All right, you have the rest of this block, which is about 7 minutes. And then you've got all of next block as a work period to finish lessons 1 through 5. Okay, and to get caught up on any lessons that you have missed.